So you're going to use your table to record the values of the weight in kilograms for each orange as it's going into this box. All right, each orange. So it's going to start with 3. It's starting with 3.
Well, that's the weight of the box.
Okay. Now we're at 4. Now we're at 5. Oh, now we're at 7. I missed one. 8. We're at 9. And now we're at 10. It was riveting, y'all. That was riveting. If you missed a data point, take a moment to ask a table next to you, perhaps. Ask a table next to you.
I do. It's 1 point.
It is now your job with your partner to graph this data on the scatter plot, and please draw the best line of best fit you can. The best line of best fit. 2 bests, y'all. All right, here is my scatter plot. It should look similar to yours. What you are going to do next, so this is going to have to go next slide for you. Well, I guess you have it on your notes. You're going to roll through now with your scatter plot numbers 4 through 9. So you're going to estimate your slope. What does it mean? Answer some questions about how many are in each box and so on, okay? So those questions 4 through 9 right now with your partner using your scatter plot. Let's run through these questions you answered. For the value of the slope, I got a slope that was about 0.2 or 1/5. And I'll tell you how I got that. I went right here and I went up 1 and I saw I needed to go like over close to 5. 0.2. Then when I looked at my table, I looked and saw like each orange 0.2 made sense. It's not always 0.2. Sometimes it's like 0.3. Sometimes it's 0.1-ish or 0.1 something. So 0.2 made sense. Some other ones I've seen today, something like 1/3.
Yeah.
I've seen some 1/2s. That's maybe stretching it a little bit. Okay.
We did 1/4.
1/4 is pretty close to 0.2 as well. So when we're doing line of best fit like this and just eyeing it and getting a slope, there is a little opportunity for variability, right? Will?
You said you went up 1. Oh, never mind.
Yeah, the scale is kind of funky, right?
Yeah.
Okay. So the next question with that slope of 0.2 was, what does that mean in context? What does the slope of 0.2 mean in context of our situation then? Emmett?
It means that with each orange, the box usually goes up 0.2.
Each orange is about 0.2 kilograms, right? That's what that means in context. We add an orange, there's about 0.2 more. We add an orange, there's about 0.2 more. Okay, next up. Estimate the weight of a box containing 11 oranges. So what I did is I went to 10 oranges, 2.569, and I added 0.2 to it. I knew how much 10 oranges weighed. One more orange to that would be 2.769 kilograms. So that's for number 2.
I just put 2.7-ish.
That's, yeah.
I got 2.
Okay.
I got 3.
It might depend on what your slope was. If your slope was a little different, I'm just letting you know what I did is I took the 10th orange and I added 0.2 to it to get an 11th because our slope says about 0.2. Remember, your slope might be a little different. Next, it asked 50 oranges. So what I did for that is I still started at my 2.569 and I added 50 times 0.2 because 0.2 per orange for me. Remember, yours might be a little different. And I ended up with 10.6-ish. So that would have been for number 3.
I got 60 and 2.
Okay.
I got 25.
Well, if your slope is different, that would look a lot different. Again, what I did is I started with my 10. I messed that up. It is not 50 times 0.2. If I have 10 and I want 50, how many more do I need? We have 40. But I did get 10.6. I just miswrote what I did to get it. Okay. Now, the vertical intercept, also known as the y-intercept, this is going to be problem number 4 out of these. Well, I guess in your notes it's not problem 4, it's just the 4th one we're doing. I got about 0.3 kilograms as the y-intercept. And that's kind of interesting because how many oranges are in there at the y-intercept? There's 0 oranges, right? So what does that mean? Yeah. Must be the box, right? Because 0 oranges would be 0 weight in oranges, right? No 0.2s. But we still would have the box oranges wherein they were on that balance, right? Okay. Next, which points fit best? So yours might look a little different because the lines could be a little different. I picked these 2 for sure. They seem to be like pretty much right on the line, right? And then which ones are the worst? I had that one being the worst. It's the furthest from the line. So depending, your line could be a little different. The best ones would be like right on the line. The worst ones would be the furthest from the line, depending on how you drew your line. All right? We all good with these oranges?
Yeah.
Okay, we're going to keep talking about food, all right? I know we're right before lunch.
Oh, I have a bag of
And we already did all those. So, next up, what we're doing with this food, this is what we just did together. Here's our food markup. Do you guys know like a store to make money? They like buy food and then they sell it for more than they bought it for. Okay. And what do you think the more expensive an ingredient would be? What do you think that is likely to do to the food?
Make it more expensive.
You would, yeah, make it. That makes sense. So you are given a graph. You are given an equation, and you're given 4 questions here to interpret what's happening in context. It's you and your partner's job to make those interpretations. Let's go. I notice a lot of people using the graph, and the graph is a great, quick visual. What's going to be more precise, though, is our equation up here. So when it says, what's the predicted sale price of something that has $1.50 ingredients, I use this.
Oh, that's true.
Right? So if you looked on the graph and you got this point right here, that's fine too, right? But which one's going to be more precise? The equation, because with the equation, I got $5.98. You think you're going to see that 2-cent difference from the graph? You will not see that in the graph. Okay. Next, it said, what's the predicted ingredient cost of a $7 item? That's our y variable. I actually plugged this in my work and solved for x. And when I solved that for x, I got $1.79.
I got $1.75.
$1.75. Yeah, you're not going to be able to see a 4-cent difference in the graph, right? Just because the scale does not go small enough. So, again, the point of this is they both do say the same thing. Which one's going to be more accurate? The equation. What does this slope mean in context, Elliot?
The slope is for every dollar that the ingredients go up,
Yeah.
then the sale of the price goes down.
So every dollar up in ingredients, sale goes up. How much again? 3? Yeah. I kind of shorthanded that just to make it fit here, but everybody see it? That's what the slope means in context. And what does the what is the y-intercept, Bella?
0.7.
And what does that mean in context?
That, like, every ingredient costs that much?
Well, at the y-intercept, how much does an ingredient cost at the y-intercept? What is x?
3.48. No. 1?
No, not at the y-intercept. Right here.
Oh, 0.76.
That's the y value. What's the x value on the y-axis?
The ingredients.
Yeah, but what value on the y-axis are those ingredients?
0?
0. It's no ingredients, right? So you might be asking yourself, if I have no ingredients, how does it cost money? What are some reasons it might cost money? Micah, give me one.
Shipping and packaging.
Packaging for sure costs money. When you go to Maya and you buy milk, you don't just say, hey, pour some in my pocket, brother. Right? You grab a package and that milk is in something. Right? Okay, what else?
Just like overall production and how stores work, they have to get a profit somehow. And
Yeah.
They can't just give out free stuff.
Production, right? Stores would have, like Meyer has stuff like electricity, heating, cooling, employees to move stuff around, marketing, commercials and stuff. That all costs money, even if there is no ingredient, right? Yeah, what else? Well, food isn't taxed unless it is like prepared food at like a restaurant. Yeah, stuff. Transport. Well, it's already there, I guess, when they buy it, but there are probably some transport costs moving it around. I think Meyer stuff usually comes on a Meyer truck to Meyer and so on. Yeah. So there's actually a lot of costs that go into things that aren't just the thing. Like when you go to a restaurant, think about why it's pricey. Well, they got to do a lot of things to have that available at your table, regardless of the price of food. Yeah. Last thing for today, we're going to kind of do this together. We're going to not speed run it, but we're going to do it together instead of you do it and then we do it together. Here are 4 scatter plots. You have equations with them. We are going to come up with what the slope means in context and what the y-intercept means in context. Okay, so this first one, we have age and reaction time. So everybody, what's happening to reaction time as we age? It goes down, which means are we faster or slower than that?
Slower.
I mean, quick is lower, reaction time is faster. Faster. And it makes sense. From like a 10-year-old to a 24-year-old, your reaction time is probably quicker, right? So, what does it say about the slope? What does the slope say? Yeah, so each year, what's happening to our reaction time is getting better by 9.25 milliseconds, okay? And then, what does the y-intercept mean?
The base.
What's the base, though? How many years old?
8.
No. How many years old are we on the y-axis?
0.
0 years old. So babies, they're at 400 milliseconds reaction time. They got bad reaction time is what that says. Okay, B. All right. So the second one, B. We've got bananas and price. What does the 0.44 mean in context? 0.44 in context. Ellie?
If you have like 0 bananas, it'll be 0.44.
0 bananas will be 4 cents. What is the 0.44? What is the slope, Hadley?
0.44. So for each banana, it costs 44 cents.
Each banana is 44 cents. Ellie, when we have 0 bananas, it costs how much?
What?
0 bananas cost how much?
40%.
Yeah, that's our y-intercept, and I think that might be the stickers.
Oh.
The stickers on the bananas.
They're also edible.
I was gonna say.
Do not eat the banana stickers. Okay, C. We got room size and cost to install. All right, so we have room size and cost to install. What is the slope of 4? Tell us in context, Micah.
That for every room set 4 square feet, it's gonna cost $1 for every 4. Or no, it's the opposite way. For every 4, for every 1 room size square foot, it's gonna cost them $4.
Yeah, it's $4 per square foot for this flooring. So why is 0 flooring $87? What could we decide in context?
Maybe
Will.
labor.
Yeah, the person to just show up, right? $87 in labor, or $87 in fixed fee just to show up, or maybe a delivery fee for the materials, maybe. Okay. And last one, we got temperature and volume. What's happening to the temperature each increase in volume?
Temperature goes up.
Sorry, what's happening to the volume each increase in temperature? As temperature goes up, the volume is going down by 2.4. So this must be ice. Usually if the temperature is going up, volume expands. But we know that ice takes up more volume than water. So I'm guessing this is water, ice to water. It's decreasing. What at 0 degrees or ice, in this case, what was the volume? At 0 degrees.
25.
Yeah, the y-intercept, 25. That's what it started as. You are all going to go back to your assigned seats and complete the lesson synthesis summary.